Recording started.
Okay, so we're going to go over a lot of this stuff fairly quickly, and because some of it's like really basic stuff. Oh, there's Aiden. Hi Aiden, how you doing? Did you have a good weekend? Right on. So we just got started here with the recording, and maybe we'll kind of catch up on some stuff as we go along, okay? We're just going to go over some of this stuff, just the basics of square roots. You guys probably know this, some of this stuff down cold, but just, okay, so we've already got the recording going, and so just remember the fact that a square root represents a number that's the length of one of the sides of a square, right? You guys know that, right? And how do you find the square root of a number? Of course, we use that sign there. You can either do it in your head, right? And if you do it in your head, remember the positive square root. When you look at the square root symbol, it actually means the positive square root. That's what that symbol means. But if somebody asks you, what's the square root of 25? There's actually two different square roots, right? It could be 5 times 5, or it could be minus 5 times minus 5. Okay, so here we got the monkey here. And the monkey's going to figure it out in his head, right? I don't know if monkeys can do that. But anyway, so that's one way of figuring out a square root, right? So you could look at all these numbers here, and you could figure out their square roots. That's one way of doing it. And here's all the different square roots, right? Another thing is you can use your calculator. Some calculators you just press, say, 25 and then the square root key, and some you press the square root key first and then it asks for the number that goes inside, right? Okay, and again, I know this stuff's pretty basic, right? Also remember, guys, that taking the square of a number and the square root are opposites, right? We call those inverse operations, just opposite operations. Okay, so in other words, you could say 1 equals 1 squared, but if you take the square root of 1 squared, it gives you back the one you started with. Okay, so you're going you're squaring, but then if you go in the opposite direction, it gives you back the number you started with. So again, squaring and square roots are the opposites, right? So I'll just ask you guys really quick, just to give me the answers for these here. So what's the square root of 36? And again, this here means the positive square root, right? Okay, 25, 5, okay, 81. Okay, good. And if I said name all the square roots of 49, what would that be? 7 and what else? Okay. And anything else other than 7? Okay, now in this case, because I said name all the square roots of 49, you could say plus 7 and minus 7, right? Okay. So it's only when you've got that square root symbol that it implies a positive square root. Hey there, Matthew. How's it going? Good to have you with us. Did you guys hear it's supposed to be plus 16 in Edmonton? So I don't know in the areas where you guys live. I know some of you guys live close to Edmonton. So it's probably going to be similar, but I don't know, Hannah, is it supposed to be pretty warm by Friday? Do you know? Okay. Yeah, and it's possible they've changed the forecast at this point, but I hope it is plus 16. Are you guys, I don't know, are you hoping that it heads towards winter right now since it's been getting colder, or do you want it to kind of stay warm as it can? Winter, yeah. Snowboard? Winter? Oh, 3 votes for the winter. I'm the only guy who likes the summer. So, hey Matthew, I was just kind of reviewing with these guys that when you see this symbol here, it implies the positive square root, but we know that there's positive and negative square roots. So for these numbers here, we gave answers that were all positive square roots, but if you had a question that said name all the square roots of 49, you could say either minus 7 or plus 7, right? Because you can have either positive or negative square roots. Okay, so we're just going over the basics here, and we're going to go over this stuff fairly quickly. And okay, so now what we're doing here, instead of estimating the square roots of perfect squares, so remember numbers like 25 and 36 are perfect squares, we're going to talk about the square roots of non-perfect squares. Okay, so we got a little cartoon here. This guy says, your mama thinks square roots are vegetables. All right, so let's look at estimating the square roots of non-perfect squares. So a number like 27, that's a non-perfect square, and so we have to estimate it because we don't know what its square root is, right? So how do we do that again? Well, what we do is we just take the number 27 and we look at the perfect squares on each side of 27. So those numbers are 25, that's the one that's below 27, 5 times 5, and the one that's above is going to be 36, right? Okay, so Hannah already says it's going to be 5.5. So let's see. Let's check it out. Okay, so we take, since it's the square root of 37, or 27 rather, we're looking at 25 and 36. The next question we have to ask ourselves is 27 closer to 25 or 36? Okay, it's definitely closer to 25. So we might want to make our estimate just a little bit closer to 5 than to 6, right? So we'll say it's around 5.2. Okay, and so then when we want to check our estimate, what do? We multiply that 5.2 times 5.2, and it should come to around the square root of, it should come to around 27, right? Okay, so we get 27.04. Okay, let's try it again for the square root of 51. So we'll use those steps. So the first step, find the perfect squares below and above. So can you guys tell me the perfect square below 51 and the one that's above 51? Okay, so 7. So right now we're just talking the perfect squares. So like you said, 49. Okay, so 49 is the actual perfect square. And the one that's above 51, what's that number going to be? Okay, and when we multiply 8 by 8, we're talking 64. Okay, so first of all, I just wanted to do the perfect squares. And after that, we'll do the square roots. And Hannah's already done for us. So instead of 49, we're going to have 7, right? And the square root of 64 is going to be 8. So we know that 51, the square root of 51 is going to be somewhere between 8 and 7. Now, do you think that it's going to be closer to 49, the square root of 49, or the square root of 64? $49. So what would you estimate as the square root? Okay, 7.3, and if we multiply it by itself, we get 53.29. That's pretty close, so that would be a good estimate. Or 7.2, either one, right? Okay, so that's that one. I'll just go over this one quickly. I'll just run by this one. Square root of 30. We find the square roots, the perfect squares rather, above and below 25 and 36, right? The actual square root is 5 and 6. And then we say, which one is it closest to? Well, in this situation, it's really close, right? 30 is almost the same distance away from 25 as 36, so 5.5 would be a pretty good estimate for that. All right. So just going to talk a little bit about algebra tiles here and algebra tiles. Okay, so first of all, what's an algebraic expression? There's a difference between an expression and an equation. You guys will probably recognize this. Stuff's coming straight from the lesson, right? So an expression is just something like x plus 5, and if it's an equation, it's always got an equal sign in between. So it's just important to know the terminology, because if the question says, you know, write an expression, then you need to write something like that. Okay, so just to review then, we're using colors here, blue and red. Sometimes they might use like a shaded or unshaded squares. So this is going to be +1, this is going to be -1. And if you're talking about, okay, so this is going to be +4, this is -6. And again, I'm just whipping by this stuff pretty quick. This is +x, the blue, just like +1 was blue. which is minus x. Okay, so if you had plus 3x, that would be these guys, minus 5x. Okay, now this is x squared when it's the big box. Positive x squared, there's negative x squared. Okay, so now we're going to get into why each one of these shapes makes sense. So why is this one plus 1? Because it's really like 1 times 1. Length and width of 1, and that's why this equals 1. Okay, so if we think about why is this x, if this width here is 1, it's the same width that we would have had if it was a small square. This is the width of 1, and this is the width of x. So 1 times x gives us x. Okay? Whereas for the big square, since this here you can see it's the width of x, right? And x times x gives us x squared. So that's why that stands for x squared. So that's kind of showing you why everything is what it stands for. Okay, and so this is just showing the different, all three of them. So again, a 1, an x, and an x squared. And the negative counterpart, you could say. Okay, so this is just showing us here, you know, with the representation of x minus 3, there's an x, there's 3 minuses. Okay, and here we've got x minus x squared, and then plus 3x. And you might get a question on the test that will ask you to change, you know, some symbols for algebra tiles into an equation and then solve the equation. Okay, so you remember before we talked about what are like terms, like 2a and 4a? Okay, just think of them as apples. If you think of that as 2 apples plus 4 apples, you say it's 6 apples, right? And then you just have to remember that you can't add like apples and oranges together. So in the same way, you can't add 2a plus 4a squared, because an a squared is different than an a. So this here is showing what combining like terms means. So again, you just pull out the terms that are alike. So we circle the ones in red that are alike, we circle the ones in blue that are alike, and then we group them. Group all the c's, and they come out to 5c in the end. The x's come out to 9x. Okay, so that's how we do that. So let's just practice this here. Just 2 questions having to do with simplifying like terms. Okay, so I'll just see if you guys can tell me what the answer would be for A. Okay, so for question A, first of all, we need to group the t's, and we have 3t minus 2t is going to give us 1t, and we can just call it t, okay? And what are we going to get for numbers? Okay, no problems. And what do we get when we simplify the numbers in A? So we're going to get, okay, we're going to get 7. So the answer is going to be t plus 7. Okay, so Aiden, how about, you were looking at this one earlier. What are we going to get when we simplify the x's? How many x's? Okay, 2x. And then we always put all the letters together, so we would put 2x and then we would just have 5y, and then what are we going to have for numbers? We have 11. Okay, so I'll just show what we did here. I'll just show it using colors so you can see it a bit better. Put the t's together, put the numbers together, simplified. Same thing with this here, x's. But for the answer here, I wrote the x's and then the y's, because we always write the variables together and the numbers after that. Okay, so those are pretty easy, I think. Solving equations. So this guy here says he's got an equation, he's solving 2 plus 2, and he says, I'm going to need tech support. All right, so now you guys know that anytime you're solving any equation, you're always trying to do the same thing, right? In the end, you want to end up with some variable like x on one side of the equation, some number on the other side. Could be an x, could be an a, b. All right. Hi, Ariel. How are you? Doing well, thanks. How was your weekend? Tiring. Oh, why was it tiring? Do you play sports like some of the rest of us or watch them? Oh yeah. How are you liking your new house? Good stuff. There's a couple of students on the school who moved in the last few months. Ariel's family, I think the Barendrecks as well. So yeah, I was telling Hannah earlier about my daughter playing soccer, and then I kind of bribed her a bit with a chocolate bar, and it worked well because my daughter loves chocolate just like me. So I told her if she did something so many times, she'd get a chocolate bar, and she got it. And so then now I'm telling her if she scores a goal, she's going to get something even bigger. And so I think I'm going to go broke with this, but it's a good thing because she did just a great job. Yeah, my daughter loves chocolate just like me. And I asked her after she got a bunch of candy last night if she's still going to be really motivated to get chocolate. And she is, I guess, even though she's got her drawer filled with chocolate bars. So go figure. My daughter never gets tired of chocolate and never gets tired of spinning. We got this spinning device, spinning toy I got from IKEA, and she can barely fit in it now, but she still does. And you can spin her around as much as you can. You let her out, she walks in a straight line. She just does not get tired of spinning. Never gets dizzy. So I don't know. Doesn't get it from me. If you spin me around, I'm very sick. So hey, Ariel, if you want to check out the earlier ones we had on the recording, right now we're just getting to simple equations, okay? And so when you're solving a simple equation, you can do it by inspection. That's why I got Inspector Gadget here. And so you can just do it in your head. You can say, okay, x is like some number. So I say, okay, some number plus 3 equals 7. So you can say, okay, that some number is 4. Or you might say, what plus 3 equals 7? Whatever. So you know that's equal to 4. You can also do it by addition or subtraction. So because you always want to end up with an x or some variable on the left side or whatever side, the other side is a number, you say, okay, what's on the left side that I don't want? I don't want the plus 3, so I do the opposite of plus 3, which is minus 3. Do the same to both sides. Now you notice here, guys, that I did it underneath. Under the plus 3, I put minus 3. Some people like that because it kind of makes it more obvious, or at least to some people anyways, that you got the plus 3, the minus 3, that it equals 0. But you can do it beside as well. You could put plus 3, minus 3, whatever you prefer. Then I put here self-check the beauty of equations. The reason I did that is that the nice thing about an equation compared to some sorts of math problems is you can always check your answer afterwards, right? So because we got x equals 4 as our answer, we just go back to the original equation, plug in the 4 plus 3, and we check to make sure that both sides equal 7. So always good to do that, just to make sure you got the right answer, especially when you're dealing with the more complicated equations, right? Okay, so this question, pretty similar to the last one, just a little bit different. Because we have a minus 2 on the left side, we want to get rid of it by adding 2. So I'm showing that here. We're adding 2 to both sides. Whatever you do to one side of the equation, you do to the other. And you're left with x equals 7. Because we have minus 2 plus 2 is 0 on this side. We get 7 on this side. Okay? So this one here is a little more challenging in some ways. You could do it in your head by saying 10 minus some number equals 7, and you know that some number is 3. If you're doing it by algebra, you say, okay, I've got an x, or a minus x rather, on the left side of the equation. I need to get rid of anything else. So to get rid of 10, I minus 10. Okay, so I'm minus 10 from both sides of the equation. That leaves me with just minus x on the left and minus 3 here. And then when you get a minus x at the end, you say, okay, what's going on? You know, some people kind of go, oh, this is not good. But all you need to do to change a minus x into an x is to either divide that minus x by minus 1 or times it by minus 1. And then you're going to do the same thing to the other side of the equation. If we times minus 3 by minus 1, we get 3. Okay, so we change minus x equals minus 3 into x equals 3. Okay? Going on to the next one. Okay, so this is just showing the steps here. So let's see if you guys can get these. X minus 5 equals 9. What would that be? Okay, and you can either do it in your head or you could add 5 to both sides of the equation. How about this one here? 12 minus x equals 4. Okay, 12 minus 8 equals 4. Good stuff. And so I know these ones might be pretty simple for some students. All right, so I'm just showing how you do it here, right? Okay. Alrighty. So now we're getting into the stuff that's a little bit more complicated, right? So here we've got, yeah, sometimes you gotta be fast with the fingers, eh? Some days I'm faster than others. Okay, so here we got, whenever you have two equations that equal one another, you can put an equal sign between them, and we can do cross multiplication, right? So we could solve this by inspection, and you might know just by looking at this that it's got to be 2 with the x equals 2, but we can also do it by cross multiplication. So again, remember, just to prove the cross multiplication is true, if we have two fractions that equal one another, just like these do, we can prove the cross multiplication works by multiplying top by bottom. 1 times 4 equals 4. Top by bottom. 2 times 2 equals 4. Since 4 equals 4, we know that it works. Cross multiplication works, right? So going back to our example, if rather than inspection we were going to use cross multiplication, we would say x times 6 gives us 6x. 3 times 4 gives us 12. 6x equals 12. At this point we have an equation that can be solved, and since we need to get rid of the 6 on this side, remember 6x is the same as 6 times x, we do the opposite of times, which is divided. We divide both sides by 6. That's what we want to get rid of. So 6x over 6 is just going to equal 1, because the 6's cancel out. Whenever you have the same thing on top and bottom, they cancel out, right? And 12 divided by 6 is 2, so x equals 2. Alright, so how about this question? Can somebody tell me what the answer would be for this one? Okay, it should say a over 5 equals 18 over 45. So if you want to just write that down on a piece of paper. A over 5 equals 18 over 45. Okay, well, let's give it a shot. Let's try it out. So what we do, remember, we're cross-multiplying. Well, at least we can. It's an easy way to do it. We say 45 times a, right? That's going to give us 45a. 5 times 18 is going to give us 90. So 45a equals 90. So we need to get rid of the 45. We divide both sides by 45. 45's cancel out, we get a, and on the right side we're going to get 2. Okay, so does that make sense? Okay, good stuff. So, moving on. Okay, so we're going to talk about some different ones here that have to do with division and multiplication. And so, just remember that 2x equals the same as 2 times x. And when you have x over 2, it's the same thing as 1/2 x. And if you recognize that, it can help. So, so here's one. 3x equals 15. It means the same thing as 3 times what is 15. You might be able to do it in your head. But remember, we're needing to get rid of the 3 by dividing both sides by 3. And this here is just showing that when you divide 3x over 3, it's the same as 3 over 3, which is the same as 1. All right. So, because we want to divide both sides by 3, you can see that here. And we end up with x equals 5 because 15 over 3 equals 5. Okay. So, what would you get for this, guys? 7a equals 28. Good, because 7 times 4 is 28. Does that make sense, guys? Yeah, these ones, I know, they're pretty basic, eh? Not too bad, eh? I was actually, you know, I made this recording here, or made it up ahead of time, and I made up 44 pages of it, and I thought it was going to take a longer time to go through it. Normally I can't go through 44 pages, and, you know, we're already like half an hour. And I probably should have, I was thinking, you know, maybe I should have included another lesson. We're on page 39, and we only go up to like 43, so we're actually getting pretty close to the end. But I was thinking that I should have maybe included another lesson on this test. But I just thought because I had so many pages that we weren't going to get through it. So anyways, so you guys might possibly find these equations fairly easy on the test here. So anyways, but I just wanted to make sure that you guys had, you know, the basics of the equations first before we went over any more complicated ones. So next test will be more complicated ones, right? Okay, so here we've got x over 2 equals 6. In other words, what divided by 2 equals 6, right? And so, yeah, okay, 12, right? So you might know when you see x over 2, you might recognize that as 1/2 x, being the same thing. If we write it as 1/2 x, and then we go on, so if we know we want to get rid of the 1/2, and we always multiply by the reciprocal, so in other words, we turn the fraction upside down, so we're going to multiply both sides by 2 over 1. So this is just another way of doing it. So again, 2 over 1 is what we multiply it by. And when we do it that way, you can see that this all cancels out to 1, so we end up with x on the left side. 6 times 2 is 12. All right, and that's an easy way, but if you want an even easier way, here it is. So that's what the mousetrap is showing, you know, straight path to the cheese. If you want an easier way, cross multiply. X over 2 equals 6, and 6 is just the same thing as 6 over 1, right? So if we write it that way, now we've got two fractions equal to one another, and now we can cross multiply. So when we do that, we get x times 1 just gives us x, 6 times 2 gives us 12, so x equals 12. And again, for this type of question, it's probably pretty easy for you guys, and so you might do it by inspection. If you get one with larger numbers, you might want to do it this way, right? Okay, so I think just have one last question, and that's it. And I really did not think it was going to go so quickly. So a over 5 equals 8. What do you think that would be? Anyone? Okay. If you want to write it down, it just says a over 5 equals 8. Are you guys, is it looking too small on your screens? Is it? Oh, okay. I got a 17-inch monitor, so maybe it looks bigger. So maybe some people's screens it looks too small, but other people it's okay. Is that right? Okay, yeah, it should be 40. And just to show how we did it. Oh, okay. So yeah, here's how we did it. If we did it, you know, cross multiplying, for instance, a times 1 gives us A 5 times 8 equals 40. And I apologize, guys, if you found this too easy. I just wanted to go over the basics first of all, and again, we'll probably see some more complicated questions like this, but larger numbers, so that you will have to use something other than inspection, when you solve them. And again, we'll be going over more complicated questions on the next test. Okay, so I really didn't think we'd get finished so quickly, but that's cool. So that allows you guys, if you got something else you want to do today. Hey, you bet. And so thanks for your participation, guys. And again, I did not think it was going to go so quickly. I know that it went by really quickly. So yeah, Ariel, if you just want to check out the first part of it. So yeah, we have our test on Thursday, and then we'll get into more complicated stuff. I mean, if you guys want, I could make up another recording on this week's lesson, and we could include that on the test. Does anybody want me to do that? Because, that way you want to stick with what we have. Okay. Well, the thing is, I know we haven't had a chance to cover lesson 10 yet, so again, the next unit will be more complicated because we'll have definitely more complicated equations in this. But I just wanted to make sure you guys had the basics of it, which I think you guys do. And so, yeah, hope things go great on your test this week. Thanks for coming, guys. Did you guys all get some candy yesterday? Yeah? I got some because my daughter's very generous. She loves candy, but she's also generous, which is nice. Yeah? I can get sick if I eat about 4 chocolate bars, like full ones. Oh, is that right, eh? Pillowcase. Yeah, I always used to use a pillowcase when I would go out. Well, my daughter is like me. She can eat endless amounts of chocolate and candy. For a while, though, she was getting lots of cavities. One time she got 8 cavities, and the next time she went to the dentist, she got another 7. And that was it was either a year later or it might have been 2 years later. But that was the point where we decided we needed to do something. And so we got her checked out, and it actually turned out that she had, some people get a certain bacteria that gives them more cavities. So she started using this mouth rinse, and then she got less of them. Yeah, I know, it's a lot of cavities, isn't it? And they wanted to do them all at once, so they just kind of, and I'm bribing her with this stuff. Well, see, there is a method to my madness, or at least hopefully. It's because of the fact that she was actually getting them more because of the bacteria that she had in her mouth than, I mean, I know the candy didn't help, did it? But now that we got her this special mouthwash that kind of targets the certain kind of bacteria that she has in her mouth, now she doesn't get anywhere near as many. So, anyways, yeah. But, well, hey guys, God bless. Great chatting with you guys, and hope you have an awesome rest of the day. All right, take care, guys. Bye for now.